All right. Hello, everybody, and welcome to the stream. Knock down the volume a little bit. I hope everybody is doing okay tonight. We're getting started a few minutes early tonight because we kind of get started a few minutes late last night. So I figure I'll make up a little bit of time there. So tonight we're going to kick off, I should say we're going to continue, rather, our foray into the Rendergraph. We're going to get our other two passes stood up, and then we're going to go ahead and start hooking things up in the testbed application. So that is the plan for tonight. Before we jump into that, though, I do want to just take a quick second and thank the supporters of the channel, beginning with our partners. Those are the highest tier of support on Patreon and YouTube memberships, and they are Arslia, Gerboles Inc., and Patrick Coolman. I'd also like to thank all the other supporters listed here on the screen. They are the other forms, or the other tiers, rather, of support on Patreon, YouTube memberships, and of course our Twitch subscribers. So thank you all very much for your support. I greatly appreciate it. Of course, none of this would be possible without all of you viewers here who follow along with the project and interact with me here on the stream or on YouTube after this is uploaded there. So I want to thank each and every individual one of you for that as well. For those of you who are new to the stream, we are working on a project called Kohi. It is a game engine that we are building from scratch using C as the programming language, and then Vulkan as our initial rendering backend. So I'll go ahead and drop a link in the chat to the project homepage. The project homepage is kohiengine.com. I'll drag that over here to the screen real quick. And this is sort of the homepage for the project, where you can find API documentation, links to YouTube and Twitch, as well as the code on GitHub. This is a completely open source project licensed under Apache 2.0, which basically means you can use the code, you just have to give me credit. With all that out of the way, let's go ahead and sort of jump into things. I'd also like to quickly mention that this is designed to be an interactive stream, so if you have questions or comments, or you just want to chat, feel free to jump into the chat there, and I will keep my eye on it to the best of my ability and answer anything that comes up. So, all right, so the last thing that we did was we basically created this scene pass, which is sort of the second part of a replacement for our render view world. So the first part of that was the skybox, and the second part of that was the scene. So that replaces this guy. And we're not quite ready to delete these files yet because we do have the packet generation stuff to replace as well. Not a huge deal there, but it is something that we need to address nonetheless. So we're going to continue with what I'm going to call the editor pass. And the editor pass simply just is responsible, at least for the time being, is responsible for drawing the gizmo. I might also move the grid to this pass, but I'm not sure that I want the grid to sort of draw over everything else, so I haven't finalized that decision yet. Okay. So, let's go ahead and I'm going to open... let's go ahead and open Scene Pass H for a second, because we're going to wind up using a very similar layout for the header file, so I just want to go ahead and grab this, and then we're going to open. It's going to be testbed lib source passes, and we're going to call this one editor pass.h. We might wind up renaming that to editor scene pass, because this is technically a scene pass, but for now we'll just call it editor. Hey Coffee, how's it going? Welcome to the stream. Appreciate having you here. How's it going? Just bumped down my volume here a little bit, so it's not quite so loud in my ears. All right, so we're going to jam this in here. We're going to replace this with editor pass, and same thing here. And then let's see, we're going to need defines. I'm not sure that we're going to need math types. I don't think we're going to need math types, so I can get rid of that. We need these, we need that, I believe. And then I'm going to do a find and replace on scene pass, and I'm going to change that to editor pass. All right, so that is basically all we need there. And I think actually all we need here is we don't need render mode, we don't need ambient color, and we're only rendering debug geometries for now. So we're only going to use the debug geometry shader. And that's actually going to be it. This is actually a super simple pass. So this shouldn't take us very long to actually implement this guy. I'm doing pretty good, Kohi. Can't complain, you know, just continuing my render graph. I'm hoping to get, well, we should be able to get the other passes done tonight, and we should be able to lay out what our frame configuration is going to look like tonight. The only part that I'm not 100% confident that we're going to get done is the actual gathering of the data, because we've got to pull that out of all these views as well. But we'll get there when we get there. LSR, good evening. Welcome to the stream. How are you tonight? Let's open testbed lib source passes editor pass.c. We're going to include editor pass h, and then pause all this stuff. Change these to function definitions, right? And I guess next thing is kind of like we've done for the other things. We're going to go ahead and do our includes. I'm going to cheat a little bit though, and I'm actually going to hop over for a second to our probably the world, or the scene pass rather. And I'm just going to grab this list. And in fact, I'm going to grab these shader locations, and I'm going to grab this internal data as well, because it's like 90% of what I need. And there's no sense retyping all that stuff, right? So I'll go ahead and slam that in here, and we'll just rename. Actually, I think we could just do our find and replace again. We don't need the material shader. We don't need the terrain shader. All we need is the color shader. All right. So, in fact, we can actually go back to our scene view, and I think most of this is actually going to, well, no, I can't reuse this section, but what I can do is I can reuse this. So I can slam this in here, and then just change this type to, again, I could just do that. All right. This check here is also going to be used here and here. And then we'll return true on success for both these guys. All right. Doing well, currently struggling with CMake learning curve. Yeah. There's a reason I don't use CMake. It's too dang complicated. Yes, it can do a lot, but the complexity to me, and also the added project dependency, is really annoying, so I never use it. that's why I roll my own. The only dependency we have for this really is clang and make, and obviously the Vulkan SDK. No CMake stuff required. Same build process across platform. But yes, I've been there with the CMake config. It's annoying. Do I write raw make files? Yes, I do. We actually have two. So we have one for our executables that we build and one for our libraries that we build. And they just take a number of parameters. When we call them from a bash script, I just pass those in. And depending on what I pass in, it's what it calls the assembly, knows where to find the files, all that kind of stuff. And it's all there. So it's also, this also does cross-platform stuff in it. So I've got stuff in here for Windows, Mac, and Linux. So yeah, we write our own here. And I haven't actually had to modify these very much in quite some time. Every once in a while I'll find something small that I have to tweak, but it's like 90% there. So I don't really have to modify it too much anymore, thankfully. And this to me is much more preferable. If you have a good make file, you really don't need anything else. All right, so let me go back. All right, so we are in our editor pass, and we need to do our initialization. So this is where I'm going to open up the editor. What is it? Render view editor world. And we're basically going to take things from here. So the first thing that we have is obviously the color 3D shader. So I'm just going to grab all of this, and this is actually all of our initialization code, right? So at least for the shader, right? So we have that section, and then we also have in our testbed main, we have configure render views. That's our world view. Here is our editor world view, right? So what we're going to take out of this is basically this render pass config. So we're going to take all of that stuff and put it here. And I think that's actually all we need for initialize, right? So we just basically have to tweak this now to make it actually fit our new structure. So this guy clears the depth buffer and stencil buffer, but it does not clear the color attachment, which makes sense. We have our attachment configurations right here. So I think what I'm going to do is I'm just going to rename this to, let's call this editor pass config. And then this will rename to, let's do editor target color. Yeah, that works for me. Do editor target color and then editor target depth. And then we just need to change this to editor pass config. And this is going to be self pass. And then we can get rid of this view stuff because we don't need that. Failed to create. We'll call this, I guess, editor render pass. And we actually don't need this anymore either. Right, so we can do that. So that's our render pass config. We create our render pass, and then we go in here and we load up our shader and pass it that render pass, right? So I'm actually going to get rid of this scoping because we don't need that here. Oops. And I'm going to combine this into one line, I think. And get shader uniform locations. Okay. So that's the shader name. Internal data, we actually don't have a cold cast for that yet. So that is going to be editor pass internal data. And that is going to be internal data equals self.internal data. Whoops. Right. We can come down here and say internal data S. Same for that. Was it? Oh, it's color shader. Okay, I guess we actually called it something in this one. Color shader. And then internal data. All right. And then we're going to do the same thing here and there. All right, so we have all of our locations, and that should be all we need to actually do. So that is our initialize. I think that's actually all we need in that. So let's go render view editor world. Let's go in here. We don't care about the event register, at least for now. We might later. Packet build, will extract that stuff out of here later. Okay. On render. So this is what we need here. Before I forget, let me come down here and move this cold cast here. And then we're also going to need another one for editor pass extended data. And that's going to be ext data equals self dot, not self. Is it self dot pass data dot extended data? There we go. Brain fart there for a second. All right, so we have our cold casts. So now we can come over here and grab, I guess start off with this, right? And then we can grab the render pass begin. And I'm going to come down here and grab the render pass end. And I know I'm kind of like bouncing around and doing this out of order, but the reason I'm doing it is because we might not need all of the logic, and so I'm trying to grab it by like the sort of logical groupings of the logic, if that makes sense. Probably a terrible explanation, but I think you guys get what I mean. All right, so this is going to be, instead of packet, that's going to be self.passData. Viewport. So we have that. This is going to be self pass. Self pass. That's going to be a dot. I think we need the address of this actually back here. That's why that's bleating. Okay, so that's good. And now we'll just say editor render pass. Why do I keep hitting that button tonight? Render pass failed to start. All right, so we've got that, and then this is just going to be the address of self pass. Get rid of this, and we'll say editor render pass failed to end. Oops. Okay. So that's the render pass. So let's see. What is the next thing we're going to need is. Okay, so see, we're doing this, which is crazy. We shouldn't be doing that. So I'm going to grab this and our geometry loop. This was one thing that I meant to kind of fix with the views that I never did wind up fixing on all of them, is that they're doing this lookup every single time, which is really, really slow, because that does a hash table lookup. That was a hack that I never wound up getting rid of. So here I can say self internal data color shader ID. It's supposed to be a dot, I think. Wait. Self-internal. Oh, because it's a void pointer, I should be just using internal data. There we go. Okay, so bind globals is going to be internal data color shader. Needs updates. How many more times does this exist? A few more times. Okay, so I'm going to do a find and replace on this. I'm going to say this and replace it with internal data color shader arrow. Okay, and then data, I guess I could do the same thing, right? So anywhere I have data, I can say internal data. Oh, that's actually not what I want. Okay, because it's capturing these as well. Am I using nvim navic to show the breadcrumb? I don't think so. I don't recall off the top of my head what I actually using for that, to be completely honest. I don't remember if that was just a... I set that bit up a while ago, so I don't fully remember how I actually got that to work. Let me see. It might be... Yeah, I don't see anything. Yeah, I'm not sure. Off the top of my head, I'm not sure. Yeah, I'd have to look through my I'll tell you what though. I do have my config is there. I'll link it in chat. So I wrote up an article on my config. It's a little bit out of date. I've changed some things since then, but that's not something I've changed. So it should be, you might be able to find it in there, and there's a link to my actual config, so you can look through it if you want. Don't you find it annoying that all the functions are in the global scope? All function names must be globally unique, right? So there's no namespaces or classes. Woo's ZX. Woo ZX. Thank you for the follow. I appreciate it. So to answer your question, Moosey, no, I don't really find it annoying. So I split my stuff up in such a way where I only ever hook up or include header files that I absolutely need. I tried to make it a point to not really include header files and other header files, with the exception of a few that have some type defs and stuff, some global type defs that I use. And I also make use of static functions in C files to avoid some of that as well. But yeah, it doesn't really bother me. I've gotten used to it. To be honest, all the namespace and stuff like that, that syntax has always kind of bothered me. So I guess I'm sort of in the opposite camp. You know, like the double colons with all the, you know, namespace, class name, blah, blah, blah. Not a huge fan of it, to be honest. All right, so we have internal data. Let's see. So our projection matrix is going to be in the self pass data. Projection matrix. And self pass data dot view matrix. So we've got that. Let me move this over a little bit so you guys can see that a little bit easier. We did miss something here. So we have internal data color shader. Okay. That looks fine. All right, so the geometry count, we're doing a D-array on packet geometries. We're not using packet geometries anymore. We are using not internal data, pass data. Actually, we're using extended data, sorry. Extended data. Debug geometry count. So we loop through that, and then this is going to be ext data, debug geometries sub I. This is going to be internal data, debug locations model, render data model. Yes, that makes sense. Then we draw the render data. Okay, I think this one is converted and done. So the only other thing we have to do is just add some logic here for our destroy. So we'll say if self, and then if we'll say if self internal data k free self internal data size of editor pass internal data, and then memory tag renderer, I think is what we're classifying all that under. Yep. Okay, so that is our editor pass. I think we're good to go. I think we've eliminated all the errors from that. So that is ported over. Let's see. Fair enough. Using just C is intriguing to me. I feel like using it for a while might make me a better C++ programmer. It very well could, because it forces you to, let me see. Because it forces you to think more about the data rather than classes and objects. Absolutely, yeah. That's one of its strongest points, honestly. You can code C like, wait. You can code C like plus more in C++. I think what Coffee is saying is you can code C++ to be more like C, which is what I did before I switched to C fully. I think that's what he's trying to say. We're going to be having ads here in just a second, by the way. Yeah, that. Okay, that's what I was saying. I called it C++ Lite when I was coding that way. So I basically was writing C, but in C++. All right, ads. We got about 50 seconds left on ads. Got about 20 seconds left on ads, and then we can get back to the stream here. Cool, and we're back. Weird Trash Can, you got Portuguese ads finally. Good. It was really strange you were getting French and German ads the other night. Very strange, but glad to hear you're getting the right ones this time. Are you still on a VPN, or... Okay, so let's see. Are there any things that you do miss from C++? The only thing that I would say that I kind of miss, but not also, would be operator overloads, because sometimes vector operations are a little bit annoying to not just be able to say times. But I feel like that also hides a lot of logic and complexity that's not necessarily immediately visible when you're reading the code. So, not really. Yeah, there's not really... I know of one thing, actually. So there's a way that you can sort of hash strings at compile time using const expression. I do miss that. And I wish they would add that to C, because I would use the heck out of that. But yeah, that's probably about it, honestly. What made me switch back? Honestly, C compiles faster, for one. Compiles a heck of a lot faster, right? Because it's simpler. I wasn't using the C++ features anyway. I wasn't using OOP. I wasn't using any of that stuff. So I didn't really see the point in using the more complex language for features I wasn't using. I was basically writing C code anyway, so I might as well just switch. Yeah, I mean, references, I guess, are kind of another thing maybe, but it's really just syntactic sugar at the end of the day. You do like the GLM library. Yeah, GLM is pretty sweet. I'm not a fan of all the templating they use in that. I'm not a fan of templates in general. But yeah, GLM is a really good library. They, of course, have a SIMD implementation in there, which we eventually also need to add to our library here. That is on the list, by the way. That's on the roadmap. I just haven't done it yet. Yeah, you use const expression for hashes, for asset identifiers, and release builds. Yeah, exactly. So there may be... That alone might be reason enough for me to use C++ for my game code. And that would probably be my only reason for doing that. GLM is C++ only, yeah. Because I really like having compile time string hashes. The only way to get around that with C is to do a bunch of preprocessor hacking, and I'm not a fan of that. But yes, that is probably the single most missed feature, I would say, from C++. Not enough to switch the core game engine to it, but it might be enough for me to actually switch my application code to it eventually, maybe. All right, so that's our editor pass. The next thing that we need to do is our UI pass. So I'm going to go to this guy, and once again, copy pasta. So I'm going to open testbed lib source passes, and I'm going to call this uipass.h, and I'm going to drop this in here, and instead of this, it's going to be called uipass.h. Get rid of that. That's going to be all the same. This is going to wind up having to change, but before we do that, let's do our find and replace. So we'll do editor pass, and we'll change that to UI pass. Right. So what are we going to need for our internal data? Well, I think we are going to need geometries, right? That's for sure. So I guess I don't think we're going to need debug geometries. So what I'm going to do is just kind of rename these. I'm going to say geometries and geometry count. We also, excuse me, we also have UI texts that we need to render, and this is a bit of a temporary measure because we're passing the entire UI text to be rendered. Eventually, we basically just need to essentially draw the vertex buffer on that, right? So we don't really have geometry that we store for that. So eventually, we'll probably just take references to the buffers here and draw those instead. But for right now, I'm going to leave it as is and say UI text, right? And then U32, we'll call this UI text count. And we'll also have a struct UI text array, and we'll just call that texts. And I think that's actually all we have for right now. So when we go to actually create like other UI renderables, we're not going to do it this way. We're just going to abstract them to something kind of like we did for the geometry, so that we could just render that instead. All right. I think that's all we need. I don't see anything else here that I'm going to need to add. So let's go ahead and copy this. We'll write this file. We'll open testbed lib source passes UI pass.c, and of course we'll include UI pass.h, and change these to definitions, and of course we'll do if not self, return false, return true, and we're going to use the same block here and here. Okay. So we are going to need some includes, which I'm actually going to go back to. Let's go to scene pass and grab I'm going to grab these. All right. So I think we're still going to need all of this stuff, including the material system, until we actually get that refactor done, because the UI uses the material system to draw as well, which is a little bit strange. And again, we have to refactor that as well. But for now, I'm not gonna do that. So we do need a type def structure for we'll call it UI shader locations. So we're gonna kind of half do the refactor here for the material stuff, kind of prepare a little bit for it. So we're gonna say U16 projection, U16 view, U16 model, and then we're going to take U16 diffuse map and U16 properties, right? And this is a property structure that we use. Spelled type def again incorrectly. I don't know why I keep doing that. All right, then we're also going to have type def struct. We're going to call this UI pass internal data. UI pass internal data. And so in here, much like the others, we're going to have shader S and then UI shader locations. All right. And here we will say self internal data equals k allocates size of UI pass internal data, and we'll say memory tag renderer, and that's all we need to do in create. And then initialize is actually where we pull out the render pass and all that stuff. So we'll go to our testbed main, and we're skipping the wireframe one for right now, and we're grabbing the UI one. So we want the render pass config all the way down to the create. All right. This is called UI pass. I want to rename this to UI pass config. This is just going to be render pass UI. We don't clear anything in this pass. We just draw right over top of the previous passes. We only have one attachment, which is the color attachment. That makes sense. Okay. UI target attachment. I guess that makes sense. I'll leave that as is for now. This just needs to be UI pass config. And then self passes. And we're going to get rid of this view stuff. Failed to create UI render pass. And we're going to delete the rest of this crap. All right. So that's the internal render pass creation. The other thing that we have to do is we have to load up the shader. So that's going to be view UI, and that's right here. actually. I'm going to grab all of this stuff. All right. Load the shader. Okay. So this should be fine. The only thing we need to do is just change this to be self-pass. This should be create. This should also have the word resource appended onto it, just so that's a little bit more clear. All right, this is going to be internal data. We don't actually have a cold cast for that yet, so we'll say UI pass internal data equals self.internal data. All right. So now we can just say internal data s. Could repeat that operation there. And then this is actually going to be locations. Diffuse map. Locations. Properties. Locations. Model. We'll go ahead and get the shader. We do not use custom shader names anymore, so that's going away. All that we are going to be concerned with is the shader name. This is going to be internal data. This is going to be the same thing. The same thing. I'm guessing kallocate is your own function that just keeps track of the tags. Yep, exactly. So, well, it does a little bit more than that. So we have a dynamic allocator, which is essentially an arena allocator. So we allocate all of our memory up front, and we dole out allocations from that. So we can completely keep track of our allocations. And those allocations, since we haven't tried to build yet, I think I can run the engine still. So I have my debugger here, which is the editor that shall remain unnamed. And when I have this open, I can just press M, and it'll actually give me this table with all of our allocations in it, right? So it'll show me all these different things. So if I have a leak somewhere, which we also keep the allocations per frame, if we have that somewhere, then I can kind of watch to see which one of these is increasing and kind of troubleshoot it that way. It also gives us our total memory usage. Out of our 2 gigabytes, how much are we actually using, right? So hope that makes sense. Coffee with the band hammer. Hey, I didn't actually say it though. I didn't say the thing. I'm not gonna ban myself. I didn't say it. But yes, so the internal allocator has a free list that it uses to manage all of that, and yeah, we actually spent quite a lot of time working on that. And we also use that as a custom allocator for our Vulkan allocations too. So all of our CPU Vulkan allocations are tied in to use that same allocator. So there's that as well. All right. I think this is all we need for now. We're obviously going to have to load some of those other locations, but I'm not going to bother with that for right now. So the execution is what we need to handle next for this. So that's the packet build stuff. The render is here. So we actually have to bind the viewport, so we need that. We need that. We also need our cold cast. This guy. And we also need... Hello, did it not? Okay, there it goes. We also need UI pass extended data, ext data equals self pass data ext data. All right, so this is going to be in the pass data. Oops. Self pass data .vp. So that's the viewport there. And then this view supported multiple render passes. We're not doing that, so I'm going to start just like I have before and actually go here and begin the render pass, come down here, grab the end of the render pass. And this is going to be the address of self pass, as is this one. Address of self pass. We're going to change this comment real quick to say UI render pass failed to start, and that's it. And then same thing here. UI render pass failed to end. Okay. All right, so this is going to be self pass targets sub render target index. All right, so that is the begin and end of the render pass. Now this one does a couple of different things. We do have geometries that we draw, similar to how our other render passes work, but it's 2D geometry. So we do handle those, and then we also handle, this says bitmap text, but it's technically UI texts, which are either bitmap text or system text. And I think, actually, I can use them as is. We have shader ID here. Shader ID is just that. Okay, so what we really need is all of this. And we'll just sort of modify this here to make it work with our new system. So I can just move this over out of the way. So this is going to be actually no, it's going to be internal data, SID. Failed to use material shader. I'm just going to say shader. Okay, so we use the shader. We apply the globals, which for now is done by the material system. So this is one of the things that we're eventually going to refactor out. But for now, we're going to roll with it as is. So this is actually going to be internal data SID. Neural Freak, thank you so much for the follow. I appreciate it. And welcome to the stream. So we apply our globals. Our projection matrix is going to come from our ext data. Or wait, no, that's our pass data. So self pass data. Projection matrix, right? View matrix is going to be the same thing. So it's going to be self pass data dot view matrix, and then the rest of these we aren't actually using. Fail to apply globals for, we're just going to say shader. So that's good. The counts, we aren't getting that way anymore. So the count is going to wind up being the self, nope, it's actually going to be extended data dot geometry count. Oops, geometry count. I spelled that wrong like 6 times in a row. Okay, so this is going to be ext data geometries. This is going to be the same thing. So basically here we just, if we don't have a material or the material is not loaded, we go ahead and grab the default UI material to use for this particular frame. We go ahead and apply the instance of that material. I don't think I have to change anything there. The local, we do have to change, and that is just going to be actually the same thing. Extended data geometries, and then extended data geometries again. Okay, so that's the geometries. That's nice and simple. Now, we don't have packet data anymore. So this is actually going to be ext data again. What did I call that though? UI pass H. I called it UI text count, but I called the text texts. Okay, not ideal, but since it's temporary, I'll live with it. UI text count. UI text. We do not actually have that included, so that's going to have to be include resources UI text. So we have that. This is going to be ext data. Oh, this should be the address of ext data. Okay. So this is going to be internal data. And then this is going to be locations and diffuse map. Weird Trash Can, welcome back. We are just finishing up our last pass for our render graph, at least for now. We'll leave this to do for font color, because that's eventually something we're going to embed into the text itself. So eventually this won't matter. Okay, so this is going to be internal data, locations, right? So that's the color. Whether it needs the updates, that actually doesn't need to be changed. What did I miss here? Oh. There we go. And then transform world get. I'm thinking this, I don't think we have this included, do we? Oh, we do, but it's, that's interesting. So it picked up the documentation comments, but it's return type int because we don't actually have it included, but it somehow managed to pick up the documentation comments. Interesting. So let's do include math transform. So we'll get the world transform for that. And then uniform set by index, the model locations. That's going to be the internal data locations model. Whoops, I missed the dot again. All right, and it looks like we're done here. So we're done with that. The only thing that we have to do now is if self, and if self internal data. We'll do k free self internal data size of UI pass internal data and memory tag renderer. And we have ads. About 30 seconds left on ads. All right, and we're back. Markeen, I think that's how you pronounce it. I hope I'm pronouncing that correctly. Thank you so much for the follow. I appreciate that. By the way, I found the reason my tree sitter wasn't working for C++, I didn't have tree sitter CPP installed. Yeah, that would make sense. It'll need that so it knows how to highlight it properly. So yeah, that totally makes sense. I don't know why I didn't think of that when you were talking about it yesterday, actually. Probably because my mind was in like 16 other places. All right, so I think we are actually done creating our passes. So now I think what we're going to do is we're going to hop over to our testbed main, and we're going to start laying out how our frame configuration is going to look. So we can get that part done so that you guys can kind of see how this is going to flow. And then the last piece of this puzzle is basically going to be gathering all the packet data. So let me head on over to testbed main. And I don't think I have, let's see. I guess I could do configure render views, and I'll do it near here. Since it's kind of replacing this, it kind of makes sense for it to be in the same location, right? So I'm going to just say static B8, and I guess we'll say configure render graph. Sure, that works. We'll need the application config. Why do I feel like that added? I think it added an include. Application config. I guess I'll just do it this way. So that's going to be config. All right. We'll forward declare this at the top when we get ready to call it. So essentially what we need to do here is we need somewhere to actually store our render graph. And I think that's probably going to wind up being on the game state itself. So let's open up game state because we actually need to handle that first. So let's do I guess I could put it under temp. It's not really temp though, but include, and we'll say renderer, Rendergraph H, and we'll come down here, and I'm thinking right here next to the viewports probably makes sense. So the first thing we'll put in here is our render graph. Render graph. And we're going to call this frame graph. Right? And then we're going to have render graph pass. And we're going to set up our individual passes here. And we're going to keep these as named structures so that we can access them accordingly. When we get ready to go ahead and fill out the data, we'll need to know which one's which. So we could do an array of these, but then we'd have to somehow index those in a weird way. And I think it just makes sense to sort of split them out. So we're going to say skybox pass. And then let's actually just, right, let's do that. And we'll say scene pass. And then we'll say editor pass, oops, pass, and UI pass. Okay. So those are all created there, and that's how we will go ahead and reference them. Okay. So let's go back to testbed main. And the first thing that we're going to need is our actual game configuration, which do we in here anywhere? Yeah, we do. Thought so. Okay, so I'm just going to copy the cold cast, right? Oops. Why did I type application config? That's not actually what I want. I want application. I was looking at this, that's why. This should be application game inst, I guess is what, God. I think that's what we'll call that. You know what? I'm going to rename it to app. Makes more sense. Okay, so we have the testbed game state. And here is where we'll actually go ahead and set up all the render graph stuff. So what we're actually going to have to do is go to the top and include some of this stuff. So where we have views, I'm just going to go right above that and include our render graph and passes. Range Bomber, I think I missed it. Thank you for the follow. I appreciate that. Okay, so we're going to include renderer, render graph, and then include passes. And we'll do it in the same order. So we'll say skybox pass, include passes, scene. I think it's going to reorder these anyways, but passes, editor pass, and include passes, UI pass. All right, just so we have those. And now we can actually start setting this up. So, I think what makes the most sense is we'll just sort of, let me think about how I want to approach this. So there's a bunch of steps that we actually need to do, right? We'll create the render graph first. So we'll say render graph create, right? So the name of the render graph is going to be testbed frame render graph, right? The application is just going to be app, right? So we need that. And then the out graph is going to be the address of state, what do we call that? Frame graph, right? Now, this does return a Boolean, so we need to check for success of that. And if it fails, we'll just say failed to create render graph, right? And of course, we'll return false there. The next thing that we'll need to do is, we'll need to add our global sources. So that would be the color and the depth resources, right? So we'll say add global sources. So here we'll say render graph global resource, or global source add rather. So this will be the address of state frame graph. The name of this is going to be, we'll go with, what do I want to call this? I guess back buffer. No, that's not really accurate. Let's call it color buffer. Color buffer. I guess that makes sense. So this is going to be a color. The origin is going to be global. All right. Does this? This does return a Boolean, so we'll check it as well. So we'll just say failed to add global color buffer source. Okay. So there's that. We need to add a second one. So I'm just going to copy pasta this. The only difference is going to be depth buffer, right? Which just means that this needs to be depth stencil. And then we'll just say depth buffer resource. All right. So that's that. Oh, Ruche, thank you so much for the hydrate. Appreciate that. Hey, Psycode. Welcome. Good evening. Abelard Greystone, nice to see you're being very active lately. Yeah, I'm trying to be. Yeah, I still can only really do a couple nights a week, but you know, we're making progress, which is good. Let's see. I feel the same way when I spend hours finding a bug just to realize it was something ridiculously simple, which it usually seems to be. LSR, that is like 70% of programming is just debugging stupid issues, honestly. I can't count the amount of times over the years that I've had pull requests that were literally one character. Yeah. Don't let it get you down. It's common. Okay. So that's our global sources for our passes to sort of hook into. So now we can actually start setting up the passes itself. So we're going to start with the skybox pass because that's the first in line. Right? And so I am going to have to check the result of these every single time. And I don't know if I really want to keep typing this all the way down. That's going to get annoying fast. Thinking I might macro it, right? So I think what I'm going to do is define RG check. And it's going to take a expression. And we're basically going to say if not expression, we will k error. Let's see. I wonder if I can do fail to execute and then literally just do that. And I think I could pass expression that way and then return false. And I think that should work. I'm not 100% sure I've got that right. I think I actually have to do that. I can never remember the stupid syntax for it, to be completely honest. We need to make an AI for finding simple mistakes in our code. So actually there's like static code analysis that can find a lot of that stuff for you, which I actually have some of that running here. C programmers and macros, name a more iconic duo. Yeah, you weren't kidding. It just happened to me. I spent the last 30 minutes trying to figure out why CMake wasn't seeing my include directories, only to realize I didn't set up one of the subprojects to compile as a shared library. See, and that's the annoying thing about CMake. To me, anyways. I know a lot of people use it. I know it's really popular. I just get annoyed by it. That's really all there is to it, right? Okay. So now I'm thinking for this, I should be able to do, so we'll say Rendergraph pass create. This is going to take the address of state frame graph, the name of it. In this case, we're going to call it Skybox. Its creation function is going to be Skybox pass create. Right? We don't want the whole thing. We just want a pointer to that, right? And then the out pass is just going to be the address of state Skybox pass, right? And then we should be able to wrap this in a RG check, which is just short for Rendergraph check. And I think that should expand to what we want. So it expands to... Good, I did get this right. So it escapes the string and everything. Awesome. I suppose I could put like line number there and stuff, but for now I'm not going to bother. That's pretty good, I think. Okay. So we have that. What this is bleeding about is we need to just return true down here if everything's successful. So the next part of this is, now that we have the render pass, the render graph pass created, we need to add a sync to it. If we refer back to our, let's see, do I have, let me switch over here to camera for a second. So if we refer back to this guy, which, sorry, I still don't have the digital version of this available, but if we refer back to this guy, right, he has one sink here for the color buffer, right? So we just need to add that sink and then hook it up to a source. So to do that, we say Rendergraph pass sync add, right? This is going to be the state frame graph. The pass name is going to be Skybox, and the sync name in this case, we're going to call this, I guess we'll call it color buffer. Right? And then we'll do a RG check around that. Okay? And so what this is basically saying is we're going to add to the render graph pass called Skybox, we're going to add a sync called color buffer. And that is going to match up to the global source also called color buffer. So we can have them be named the same thing as long as we don't have two sources and two sinks named the same thing. That's fine. We can have a source and a sink named the same thing. We just can't have duplicate sources and sinks named the same thing. Let me see. I only use CMake apparently because it's possible for me to learn make files. It's really not impossible. It just involves a lot of Googling, to be honest. I initially started learning CMake thinking it would be simpler than Makefiles. It's absolutely not. I could build my project in one day after learning basic CMake, and even after 1 week of trying, I didn't manage to figure out Makefiles. Makefiles, I guess you could say, are... I guess you could say they're kind of like using Vim, right? Like, the learning curve for them is pretty steep, but once you get it, and once you have it sorted, like, you really just don't ever have to, like, worry about it again. Like, once you're there, you're there. The nice thing about CMake, you can set up a simple project build fairly easily. I feel like it gets confusing when your projects scale, having multiple subprojects. That is my issue with CMake. It gets very complicated very quickly when you have anything of scale. You're trying the forbidden IDE name with ClangD instead of IntelliSense, and it feels so much better. Yeah, and ClangD is what powers all of my completion stuff here too. So yeah, it hurts even thinking about having to write CMake or Makefiles into these kind of projects. Gonna buy biscuits. Be right back. Okay. Going down the pipeline one sink at a time. Yep, basically. Honestly, a lot of this code is going to be repetitive, so like once I write out the first version of it, I'm going to wind up copying it for some of the other passes, right? So we've added a sink for the color buffer to our Skybox pass. Now we're going to say Rendergraph pass source add. So this can basically be our output, right? We're going to output to a new source. So we're going to say state frame graph, and then pass name is going to be Skybox. And source name, we're going to say is color buffer once again. And then the source type is going to be color. And the origin is going to be other, meaning it's owned by something else, right? It's internal original source is owned by something else, right? Which is this global up here. Incidentally, we may wind up getting rid of these enumerations. I haven't completely decided yet. It'd be a lot nicer to not have to declare those all the time. The origin specifically may not actually matter. But for now, I'm going to fill it out with it in there. So we have our RG check to add. right? And so now we've basically said, okay, well, we have a sink for its input, a source for its output. And then what we need to do now is we need to actually link all that stuff together. So we say Rendergraph pass set sync linkage. And so again, state frame graph, the pass name skybox, right? The sync name is going to be color buffer, right? The source pass name is actually going to be nothing. So we're going to pass 0 here. And if you recall, whenever we say that we want to pull something from global, we don't pass a source pass name, right? And that is basically how we determine the linkage, right? So that's one of the reasons I'm saying I don't think we're going to wind up actually using this source origin thing. So the source name is also going to be color buffer, right? So what we're saying here is we're setting the linkage on the skybox pass of the color buffer sync to the global color buffer source, right? And so we wrap that in a RG check. And that is how we create a pass, or how we add a pass to the render graph, right? It looks kind of complicated, but it's actually not. And so we basically just have to fill one of these out for all of our passes. And for now, the order that the passes are added is the order that they're executed in. Eventually, we'll do some dependency resolution to figure that out. But for right now, we don't have that, right? So this is just sort of the first step. So that's our skybox pass. And our scene is going to be very similar. It's just going to have another source and another sink, essentially. So I'm actually just going to copy this. And I'm going to change all of these to scene. Right? And then this source here, this source name is going to be skybox. Right? And so, let's see, this also needs to be changed. So this is going to be scene pass create, and then this is going to be scene pass, right? Also, we need to make sure that it's pointed at the right pass, scene pass, right? So we create the scene pass, we add a sync to it called color buffer, once again, right? We're also going to add a second sync to it, to the scene pass, right? And we're going to call this one depth buffer, right? And then we're going to add a second source. So we can copy this. And this is going to be, as you might have guessed, depth buffer. And the only thing we need to change is the render target to depth stencil, right? Everything else is the same, right? And then as far as the setting the sync linkage, it's going to be largely the same. However, we are going to do depth buffer. And again, since we're not taking the output of another pass on this, this is going to wind up being 0, right? Because we're pulling it from global. And then we're going to do depth buffer here. Okay? And actually this should be global. So I hope that makes sense. All right. What exactly is a render graph? So I'll tell you what, we actually have an ad coming up here in a minute, so I will re-explain the concept as soon as the ads are over, right? I don't want to get halfway through it and then have to re-explain it. So that's 2 of our passes knocked out. So our editor scene is basically going to wind up being, or our editor pass rather, is going to wind up being pretty much the exact same thing as this. So, and we have ads. All right, we're almost done with ads. Okay, so what we're actually going to do is I'm going to redraw this really quickly and just kind of re-explain the concept of a render graph. So a render graph is the configuration of a frame, basically, right? So we're going to draw a big old box here to represent a single frame of the application, right? This is one frame that we actually draw within the app. Within that, we have some global resources that we work with, right? So we have a color attachment / output, right? Or color buffer, if you want to think of it that way. And we have a depth buffer. Okay? And so those are sort of globally owned resources. And so what we do is when we talk about global sources is we link those to what we're going to call a source, right? So each one of these has its own individual source. So this one becomes a source called, I think we called this color buffer, right? And this one is called depth buffer, right? And then what we have is we also have a concept of passes, which are render passes. And render passes essentially operate on these guys, right? And so we're implementing 4 render passes right now, we should say render graph passes, right? So we have 4 of these guys. I'm trying to do this so that I have enough room for everything. And each pass has its own set of what we call sinks, which are, you can think of them as sort of sockets that take a source, right? So we have this global source here called color buffer that plugs into our first sink on our first pass. So this is our skybox. This is our scene. This is our editor. And this is our UI, right? And so each one of these things has different sources and sinks that it uses and works with. So we're using the color buffer source here, the global one, and we're plugging that into a sink on the skybox called color buffer. And I'm just going to abbreviate that to CB, right? And then that outputs a source also in this case called color buffer, right? And then our next pass has two sinks, right? And so the first sink is our color buffer, and our second sink is our depth buffer. Sorry about that terrible arrow there, right? And so this one takes the source that was output by Skybox, plugs that into that sink right here. And the depth buffer is obtained from the global depth buffer in this case, right? Terrible line, but you get the idea, right? And then this scene outputs two sources, right? So again, our color buffer and our depth buffer. And I dropped my pen. And the editor pass also has two sinks. And those plug right in, right? So again, we have our color buffer and our depth buffer, right? Now the editor pass outputs to two sources, right? So again, similar to before, we have our color buffer and our depth buffer, right? However, at this point, we're actually done with the depth buffer. We don't plug it into anything. We output it in case we have some other pass that needs to use it, but at this point, we don't really need it anymore, right? And then we finally move on to the UI pass, which doesn't use depth. It just has a single sink for color buffer, right? So we plug that guy in here, right? And we render that, and that outputs just a color buffer source, right? So that's color buffer. And then at the end of the frame, and I kind of ran out of room here, but at the end of the frame, I'll just put it over here. We have a global sink, right? And this global sink is for the color buffer. And this guy is eventually what winds up getting presented, right? So we present this guy. And so what we do is from the final pass, we say, okay, take the color attachment and plug it in here. And at that point, our pass is ready to be presented, right? And so the purpose to doing all of this is, let's say, for example, that we just wanted to conditionally exclude the editor, right? Let me actually use black to do that. Can I undo this? Yeah. All right, so let's say we wanted to exclude the editor, right? You could very easily then just take this and plug it down in here to this, and then just not do anything with that, right? And so the idea behind us using strings to name all of these individual things is that we'll eventually want to read this in from a file and maybe even an editor itself, like a node editor, to be able to actually configure all this stuff. So that is basically the gist. All right, so I hope that makes sense. Started to make sense. Cool. Put it in the present queue and ship it. Exactly. So that is what we're building here. So we're basically just configuring this for right now in code. Eventually we'll read it from a file, right? And that's kind of what we're setting up here. All right. So we have the scene pass. And our next pass over here was the editor pass, which is almost identical, right? So editor pass. So we just need to change this to editor all the way down. Right? We need to have this say editor pass create. This needs to be editor pass. And then we have the same sources and the same sinks, actually. The difference being is the depth buffer now does not have an origin of global. It has a origin of other. All right, so our sources and our sinks, as we kind of went over in our image, are the same. Our linkage is going to wind up being 90% the same. Only the difference is instead of our source being skybox here, our source pass is going to be seen, right? And then for the depth buffer, our source pass is also going to be seen, right? Otherwise, it's pretty much the same. Okay. Let's see. The depth buffer doesn't need to be presented to the window. Correct. So that's why we have, that's why I X this out down here, right? Because this doesn't have to be presented. We still output it on this pass in case we have some other pass that needs to use it. We still output it as a source, but we may not actually wind up using that, right? So that's why we do that. So yeah, we only have a global sync for the color buffer. Yeah. Okay, so that is that. And then the UI pass kind of looks a lot like the skybox pass, so I'm actually just going to copy it because it's pretty close to what we're going to be dealing with down here. So let's rename this to UI pass, and we're going to call this UI. And we're going to say UI pass creates, UI pass. We have one sync, which is the color buffer. We have one source, which is the color buffer. And that's source origin of other. And then the only real difference is instead of getting this from the global source, we're going to get this instead from the scene, the editor output, right? And so that's basically saying just grab the source as it was from the editor color buffer source, right? So that is the UI pass. There is, I think that's actually it, right? So this global sync that we have here for the color buffer is automatically stood up for us when we create the render graph, so we don't actually have to do that here, because any sort of render graph is always going to have some sort of color output. I think I'm making that assumption for now. If that assumption winds up being incorrect, we can always change it later. So I think what I'm going to do is we'll go ahead and say, well, let me think about this for a second. So there actually is one step that we need to do before we can actually finalize the render graph. And that is we need to set up pointer functions on all the passes, right? And so actually if we look at, let me go to render graph H. If we recall, our render graph pass has initialize, execute, and destroy function pointers, right? And our render graph is actually going to need to know what those should be for each one of these things. Function pointers are one of those weird things where whenever you do a hot reload on a library, you actually have to reassign the function pointer. So what we're going to do in this case is we're going to set up a function to assign these function pointers to us, or for us, all at once. And that's going to allow us to hook into our hot reload logic to allow it to automatically set up all that stuff for us as well. So to do that, we're going to say static. I'm just going to go with a void on this and say, I guess, refresh render graph PFNs. This is going to take... Do I need the whole application state for this? Yes, I think I do. Application... we'll call this app. And basically we're just going to do the same thing. Whoops. We're going to do the same thing as we did here. So we need the state. And we'll basically just go through each one of these and sort of hard code assign them. So we'll say states, skybox pass, and we'll do initialize first. And then we'll set this to skybox pass initialize. Is this going to allow me to do it without? No. All right, whatever. Right? Right, so we can just say initialize. We need initialize execute. And destroy. Right, so this is going to be execute and destroy, right? And then we can basically just repeat this process. For each one. So instead of skybox pass, it's going to be scene pass. Right, and then scene pass, scene pass, scene pass, right? So I'm actually just going to put this in here twice. RGU William, thank you so much for the follow. I appreciate that. So instead of scene pass here, it's going to be editor pass. Oops, what did I do? Okay. Editor pass, and then this guy down here is going to wind up being UI pass. Right, so this will just be editor pass. All right, I don't know what that just did. Editor pass, and then UI. All right. And that's always going to succeed, so I'm not going to bother with a boolean there. And down here, we'll just say refresh Rendergraph PFNs, and we'll pass app. Right? And now we can actually finalize the Rendergraph. And I think that's actually going to be the last step of this, right? So we can say Rendergraph finalize, and we'll pass the address of state frame graph. Okay. And I think, does this... It does return a boolean, so I'm going to do an explicit check on this one. Instead of just a RG check. Failed to finalize Rendergraph. See log for details. Return false. And that, folks, is the setup of our Rendergraph, which is awesome. So we have that done. What happened? This should be create. Not sure how I missed that one. Okay. Magniferox, I am rewarded for random insomnia with the ability to catch another stream actually live. Awesome. Well, not awesome with the insomnia, but I've been there and done that. I know what that's like. I know what you mean. Good insomnia, yeah. Insomnia can be good, I guess, in the short term, but in the long term, not so much, right? Okay. So there's a couple things that we need to do from here. So this is basically the creation of, oh, you know what? I don't think I made, I need to forward declare this before I forget. So let me go up here and put it there. Right. Okay. So we have our render graph set up, our function pointers set up. It should all link. All of that I think will work. Unless I've done a typo, which is entirely possible. So the next step of this is going to wind up being, we're going to go through the steps of gathering all of the, what we called packet data before. And we're going to basically fill out the pass data on each one of these individual passes during the update loop. And I'm going to do that synchronously at first, just sort of in a top-down fashion. But after that, after we get that working, we get the render graph up and running, and we remove the views, or maybe before we remove the views, we'll see if we can actually get that working in a multi-threaded manner, right? Where we can fire off a few of those processes to happen at once, and then perhaps be able to come back and wait for all those jobs to complete, and then proceed on. It's mostly the horrible hot weather. Yeah, I mean, it's been a little bit hot up here where I'm at as well, but thankfully today it cooled off with a lot of rain. But did I manage to take a peek at Path of Exile at any point for the renderer being changeable without shutting down the application? So I did a little research on it, and it looks like that is a thing, which is actually kind of cool. I haven't downloaded it or played it, but that is interesting to me. So it might be something that I do. I don't know that there's a whole lot of value in doing that. I could see the value in switching from like DirectX 11 to DirectX 12 without having to reboot, but I don't know. I don't know that I'll wind up supporting it, just because I don't know that I want to mess with having to maintain all of that state as well. But then again, we also hot reload a lot of stuff too, so maybe it won't be that hard. Yeah, it definitely is possible. The only difference would be making sure that we basically have more than one backend loaded at a time, which actually, it really would just mean being able to hot reload our backend when you think about it. It's a little bit more than that though. So we'd also have to detect on the front end if the backend actually changed APIs and then re-upload all the stuff. Dota 2 can change from Vulkan to DirectX. Yeah. That, I might do that, but I don't know. I don't know if it's worth the trouble, to be completely honest. Like, if I was writing an engine that was going to be used by a company like that, I'd probably go through the effort. But for something of this scale, I don't know that I'd mess with it. Cuts down the potential time overhead hunting graphics bugs across renderers. You could also just run multiple instances of the game to do that. I mean, in theory, right? I don't know. But yeah, I see what you're saying. I mean, there definitely is value in it. There's no arguing that point, for sure. It's an interesting thing to think about, for sure. Shader hot reloading is likely very useful. So, yeah, I would say shader hot reloading is absolutely useful. That's actually something that I'm hoping to implement at some point, because I really want to get rid of the post-build process for Vulkan, and do it within the back end, right? Like, because that's what like OpenGL does, for example. The only downside to doing that is like you wouldn't want to do that in production code. You would only want to do that in debug code. So I'd have to figure that out too. It's just a complex thing standing up all the renderer state while the application is in flight. Exactly, that's the problem. Because you would basically have to, when you're swapping that out, in the middle of a frame, you'd have to go, okay, stop. Figure out what we need to load, what's loaded, what's unloaded, and reload all those things into the GPU, and stand up all those resources, and hook up all those links, and then go. And that's not as easy as it sounds. But yeah, shader hot reloading we're definitely going to be doing. For sure. You probably want to wait for a frame to end to do that. Well, yeah, I mean, when I say in the middle of a frame, I mean either immediately after presentation or when we start presenting a frame, like maybe we just cut it off right then and there and just don't do the rest of it, right? Depending on if it's like if it's something that could be triggered from outside the main thread, which theoretically it could be. That's another thing you have to consider. But yeah. Okay, so I'm trying to think. I guess we could start taking a look at gathering some packet data. I don't think we're going to get very far with that tonight. But we can take a quick look at it. So, let's see. We're going to want to put that in prepare render packet. We might actually think about the way that we're doing this in general. So I think we're going to have to actually change our application interface again, because this is pretty specific to render packet stuff, right? So our general flow is we have update, prepare render packet, and then render, which is fine. And I want to keep those steps separated, I think. But this is actually using the struct render packet, which we really aren't going to need anymore. I'm actually doing away with that. We're also doing away with all this stuff, right? So like this populate render packet thing that we're doing here is actually going to end up going away, and the steps that are within that are what we're going to use instead to fill out the pass data. It's a little bit more than I wanted to bite off and chew tonight. Let's try this. So let's go ahead and commit what I have so far. For manually switching it back and forth in PoE, it looks like the frame for at least part of it is still running ahead with the gameplay input audio while the render assets are being reloaded. So it's kind of running headless, but only missing a section of the head. Which, as long as your update loop isn't doing anything that would be updating any render resources, you'd be fine doing that, unless you know to also not do that. Or skip the updating of those render resources. Ugh, that sounds incredibly dangerous, though. I don't know. I'm just thinking of all the ways that can go wrong in my head. You'd basically have to design the engine to do that from the get-go, and this engine's not really designed to do that. Not saying it's impossible, but yeah. Headless is kind of interesting, though. Theoretically, I guess there's things that we could use the engine for that would be headless. So I suppose we could have like a headless renderer plugin as well, where we just don't actually write anything to the screen whatsoever. And that would be for like, if we needed to simulate world physics or something on a server, we would do that. So there is use in having like a headless engine running. It's an interesting concept. I'm gonna do some more thinking on that for sure. All right, I'm just gonna go through the diff on these main files here just to make sure that I didn't miss anything. Don't have any nasty to-dos or anything like that. I don't think I do. Cool. So initial, what did we do? We did the editor and UI pass commit. Also stood up frame render graph config. Oh, I missed ads. All right, and we're back. I hit the ads button a little bit late there. So I've gone ahead and checked in what we have so far and pushed that up to the feature render graph branch. So if you guys are happening to follow along, that code's available to you. We haven't actually activated it or called any of it yet, so it doesn't actually do anything at the moment. We'll leave that until we actually have all the pass data collection stuff up and running. Because the next step is basically to re-emulate all of this stuff that's happening here, which actually isn't that much. We basically just have to translate it, right? I'm not going to get through that tonight, I don't think. So, all right. I think running a headless mode is also a decent way to buff up an automated integration test suite, like the gameplay modules. Sans had a super fast speed to get through verifying a bunch of integrations. Yeah, it could also be used for integration tests for like the physics engine, right? Because the physics engine doesn't care about a renderer. So you could simulate stupidly fast things there as well. So yeah, I definitely think having a headless renderer could be super valuable, actually. It'd be interesting to see how that would run, to be honest. You'd almost have to have... I mean, you're still going to get like a window, at least the way that we have it right now. But yeah, we could theoretically do that, actually. Or what might be an interesting experiment too is having a software renderer too. Might be fun. Even though it won't be fast, it might be fun to actually make a software renderer. Dropping boxes on things at high speeds, yeah. Setting the traffic speed to 999999999 might be a lot of fun. Have you guys seen the videos on YouTube of that, where like some guy took a Grand Theft Auto 4 and set the traffic speed to like 9999999, and he tries to actually do the missions? It's hilarious. It's the funniest thing I've seen in a while. Really, really good entertainment, that. Yeah, it is super, super funny. I just pull one of those up when I need to laugh. Like if I'm really like frustrated with a problem that I'm working on for, you know, work or whatever. I just pull one of those up, and after 10 minutes of that, I'm good. All right. All right. I think this is probably a good spot for us to end, because the next step of this is going to be refactoring this, and I really don't want to jump into that tonight. So I think this is probably where we're gonna call it for tonight. So really quickly, I'm just going to drop my socials in here so that you guys have access to all of that stuff. It's basically my YouTube, Discord, GitHub, Twitter, Patreon, Kofi, all that kind of stuff. So if you guys haven't already, follow me in those places to get updates, because sometimes I post things to Twitter and whatnot, that I don't necessarily post to like YouTube or Twitch, right? So let me see who is online that I can raid. Jonathan Blow is playing Starfield. Maybe we should raid him. I'm kind of interested to see what he thinks about that game anyways. I think that's what I'm going to go with for tonight. And yeah, so that's where we're going to end it. Thank you guys so much for joining. I really appreciate you guys here. And we will be streaming again next week. Next Wednesday is going to be the next stream. So look out for us there. And yeah, we will continue this then. Cool. All right. Thank you guys again. Don't forget to toss me a follow if you haven't already. I really appreciate that. And go ahead and hit up the YouTube channel as well. I dropped that link there. All of this stuff gets archived there. Plus, I have some other additional content there as well available for you guys. Anyways, I will see you guys next time. Peace.